Hello, my name is Justin Rush, and this presentation is on big data. Big data is a relatively new concept to the IT industry. Many companies are using big data-based technologies today to help them sort through the large amounts of data they are collecting. However, simply processing and storing that data is only a small part of the big data problem facing most companies. The real challenge is for companies to extract value from the data they are collecting. Data can be collected from many different sources that we'll go into more detail on later in the presentation. Companies that are able to analyze the data they receive and turn this customer data into value have a huge advantage on their competition. There are many different big data solutions available, and even more companies are starting up each day. As the world continues to create more and more data, it becomes increasingly important for companies to be able to create benefits for both themselves and the consumer. The term big data was originally coined in 2005 to describe datasets that were so massive they could not be managed using the IT solutions that existed at that time. Money projected to be spent on big data solutions, as well as by big data companies, will eclipse $200 billion in just a few short years. Like mentioned in the intro, companies all over the globe are popping up to help other companies implement big data solutions within their organizations in an attempt to extract value out of all the data they're currently collecting and storing. These companies include newer companies like Pivotal and Hortonworks, as well as powerhouse companies like IBM, Amazon, and Microsoft. We certainly live in a world of information today. It's estimated that we created over 5 exabytes of data from the beginning of society until about the year 2003, and now that same amount of data is created once every 2 days. This slide shows just a couple examples of how much information our society really creates. Over 300 hours of video are uploaded to YouTube almost every minute, and in 2015 alone, over 1 trillion photos were taken, billions of those shared and posted on social media sites. It's very evident our society has taken a big leap over the past decade, and even though technology has come a long way, there is still a very long way to go to catch up with the amount of data we create every single day. Before we dive deeper into the technology behind big data, it's important to understand some concepts surrounding the data that we are creating. The first distinction that we need to make is to determine whether the data is internal or external. Internal data is data that is created by an organization and it's not accessible to the public. This data typically resides behind a firewall or other secure methods to ensure that only members of that particular organization can access the data. Not only do organizations create new data every day, but they're constantly storing and archiving data for historical and legal reasons. For example, most companies need to retain tax documents for at least 5 to 10 years or longer, depending on the type of document and the other situations surrounding the organization at that time, such as an audit. Not all data, however, is produced and housed within an organization. External data is the other type of data, and has become more and more valuable in recent years. Most companies use external data for research or to complement data they may already have internally. This external data can come from customer transactions, social media, weather, or the ever-growing Internet of Things. The next distinction is between structured and unstructured data. Structured data is in a fixed format and comes in the form of a dataset, record, or file. This record has specific fields and field types that are often limited to a set number of characters. The rigidness of this format makes structured data very easy to process. Unstructured data, on the other hand, is very unorganized. There's no set file structure, and IT experts don't know what to expect when processing this data. A good example is social media posts, which can contain text, pictures, or even videos. Finally, an API is an application programming interface. Data sources with an API make it much easier for companies and individuals to interface and access this data. Along with different data types, data also has different attributes. First, velocity. The velocity of the data refers to the rate that it can be produced and changed by the source. Second, the variety. This includes the number of different sources and types that currently exist or interface with a company or individual. And finally, the volume of the data, which is just the average amount of data being produced, received, or processed. Now that we've covered some basic definitions, we can start getting into the actual sources behind all this information. First, the Internet of Things. The Internet of Things is a relatively new concept to the IT world, and most IT professionals struggle to understand what the Internet of Things really is. It simply is the number of objects that are connected to the Internet. The Internet of Things includes TVs, smartphones, and even home appliances, many of which connect to the Internet today, like refrigerators and washers and dryers. The number of devices connected to the Internet is projected to grow by 50 billion by the year 2020. And not only do these devices connect to the Internet, but they stream data as well. For example, a company that makes thermostats that connect to your home Wi-Fi can now receive data like the average temperature that you keep your house. Refrigerator manufacturers can see the temperature you're keeping in your freezer, while washer and dryer companies can see how often their products are used and at what settings they are most likely going to be used at. This is a small fraction of what can be done with everyday devices that connect to the Internet. The next question that most people ask is how much of my data is really visible to these companies, and do they have the right to do this, which we'll get into a little later in the presentation. One of the newest technologies to be collecting and storing data is sensors. Sensors are being used more and more frequently by companies to create huge, real-time data sets. By transmitting data in real time, this means that data is constantly flowing from a sensor or a group of sensors to a database within a company. Sensor analytics itself is becoming a huge field due to the large volume of data that sensors are capable of producing and transmitting. A great example of sensors in today's world is within the automobile industry. Modern cars can transmit over 25 gigabytes of data to the cloud every hour. For comparison, if modern cars were transmitting data to the average smartphone, the phone would run out of space in under 30 minutes. Another great real scenario is in Asia, where sensors have been placed within different points in different cities to monitor air conditions in real time. The main takeaway from the increased use in sensors is that the raw volume of data being produced is increasing, and this is posing a big challenge for organizations to be processing and extracting value from all this data. Finally, the internet is obviously a big source for big data, especially with the rise of social media sites over the past decade. On Twitter, there are over 350 posts per minute, and on Facebook, that number is 3 million posts per minute. In addition to this, likes, shares, photo tags, and more add even more information to this already huge amount of data. Even the US government has recently pledged to make all their data freely available online. This includes everything from climate data to crime information. Another notable organization to make their data freely accessible online is the US Census Bureau. This data includes all information related to population, education, and geographic data. Another notable source of data from the internet is Google, with their Google Trends, Google Finance, and Google Books spinoffs. Google Trends can be used to analyze search volume for any term since 2004, while Google Finance includes up to 40 years of stock data and is updated in real time. Finally, Google Books is a project that allows users to analyze text from millions of books that have been digitized by a team at Google. This slide showcases many of the things we talked about in the previous slides, such as social media sites, Census Bureau data, sensors, and the Internet of Things. While the sources listed are the notable sources of big data, there are many more out there, and this is only a very small sample size of the sources of data that exist in the real world. Now we can get into the technology behind big data. For companies to process and analyze the massive amounts of data they receive, it takes a system that can handle the complexity, memory storage, and computer processing needs for the large data sets they receive. For many people, the terms big data and Hadoop go hand in hand. This is for good reason, as Hadoop is the most prominent technology associated with big data. Hadoop is an open source Java-based framework that is able to process and store extremely large amounts of data through its distributed file system. A distributed file system essentially makes copies of a database and allows clients to access it as if it was on their own computer. The real key to this is maintaining a mechanism to ensure that two clients cannot access and update a single file simultaneously. By spreading the data across multiple machines, it also helps to protect against potential data failures in the system. Opposite of distributed file systems is MapReduce. MapReduce can be implemented in many different programming languages and serves the important purpose of distributing and organizing the work for each client. An example of Hadoop in action would be the task of finding how many times a word appears in a collection of websites or a book. MapReduce would essentially split the task among a set number of machines in order to complete it more quickly. If one machine were to become disabled in any way, a different machine would step right into its place. This shows off the fault-tolerant aspect of MapReduce and Hadoop as a whole. Since Hadoop is an open source software, it allows companies to use it and create their own platforms and frameworks they can spin off into companies. For example, Hortonworks is a new company that focuses on delivering Hadoop solutions to large organizations. Organizations can even use a combination of the companies listed on this slide to get different aspects for their Hadoop framework or foundation. My company uses a combination of Hortonworks, Pivotal, and Teradata in their solutions. There are essentially two parts to big data: data processing and data storage. Before we talked about data processing, and this slide will focus on data storage. Data storage has come a long way, and this has been a necessary advancement for big data technologies to be successful. Companies continue to generate more data each year, as we've seen in previous slides, and once all the processing is complete, this data needs to be stored somewhere for future reference and archiving. The key aspect to big data storage is scalability. Cloud options like Pivotal, Amazon, and Google have recently become the trend. The big advantage with cloud storage is the scalability of server space. While some companies like the security of housing their own servers and data center, it is not always feasible and does not provide the scalability necessary for big data storage. Cloud solutions are easy to scale and allows companies to start small and then grow as their solution grows with it. Data storage has come a long way and has made mass data storage more accessible and available than it ever has been in the past. Now that we've discussed the background and technology behind big data, it's time to discuss why companies are implementing big data solutions. The reason behind companies implementing big data solutions, or any IT solution for that matter, is value. This value can come in external ways or internal ways. First, let's discuss the value to internal customers. By collecting and analyzing information internally, it can help make informed decisions about business segments, product lines, or other departments. On the other hand, using external data, companies can add value for customers or even directly see an increase in profits. Many companies are using big data to gather and store information about customers or potential customers. This can come from previous purchases, online activity, or social media. By tracking this, companies can specifically target potential customers with personalized marketing campaigns and send personalized discounts and offers for products that someone may have viewed online or liked on social media. While we've mostly explored the benefits from using big data, there are some problems and risks that can arise, mostly surrounding privacy concerns. Consumers are finally becoming aware of all the data that companies are collecting from them, and many consumers have an issue with companies tracking things like online activity or social media presence. Data breaches continue to make the headlines, such as the breaches that affected LinkedIn and Target, where over 200 million people were affected in total. In Target's case, they are in the midst of paying back up to $10 million to those affected by their data breach, and this is a small price to pay compared to the potential loss of customers and revenue due to the news coverage that their breach received. In today's world, public opinion can greatly shift the outlook of a company, and companies must be very careful when handling customer data of any kind. Big data has been a big topic over recent years and will continue to expand in the emerging area of IT. With society creating more and more data every day, big data is only becoming more important for companies and organizations. By implementing big data solutions, companies can work to increase the value to both internal and external customers and can lead to increased profits, sales, and customer satisfaction. Thanks for watching, and I hope you enjoyed this presentation on big data.